Okay, so yeah, we're good. Cool. Okay, so let me share my screen. Um, and I want to, so I think there's a, okay, great.
Your audio is perfect.
Great. So, yeah, so I'm here to talk about Forthic, and this is a high-level Forth. So it's kind of the opposite of everything that we've been talking about so far. Because instead of like building something from the metal up, I'm just saying, forget that. I'm going to start from the top. And the motivation was, so I worked at LinkedIn, and I built a lot of tools at LinkedIn, but I needed to build them like really fast because I had a lot of people coming in and asking for things, and they wanted like really custom things. And at the time, I'd been playing around with Forth, and I thought, hey, Forth would be great for building up these types of tools. But the downside, and Brad, thank you for talking about JSON because I don't have to talk about JSON. But the downside and strings and APIs and all of this, and I was like, okay, Forth is not really like built to handle that type of thing. So I wanted something Forth-like, but I wanted to stay on the top of the app. So that's where Forthic came from. And so here, what I'm showing is a couple of examples of some of the apps that we built. So these are 9 examples, and they were all kinds of different things. You'd have dashboards, email campaign managers, automations, things that created G Sheets, things that created wiki pages. And so like it was just saving tons and tons of time. And because I was using these Forth-like concepts, I was able to build them like very fast. And I was going at 100 per year. And so over 5 years, we had like 800. And you're saying, okay, how does that add up? Well, it adds up because the program managers and the engineering managers that I built these tools for were able to clone them and tweak them. And so that's where the other 300 came from. So we had this kind of wonderful ecosystem of things happening. And so I want to say a little bit about Forthic's design. It was incomplete on purpose. And so it needs a host language to run in. So unlike the Forths that we've been talking about here, where you're kind of building up a Forth system and then building things on top of it, I just punted on that and said, I'm always going to need a host language to run in. And the primary ones were Python and JavaScript. I have a TypeScript one that I'm going to say open source as well. But when you do that, then there's a couple of implications. And oh, by the way, so some of the other examples, if you're curious, this is on GitHub if you want to take a look. But we have one in C++, Haskell, Julia, NVIDIA, C++, a tokenizer in Rust, a Swift version, a tokenizer in Zig, and some earlier ones that were where I was trying to build like a true Forth. So you have assembly, C#, Lang, and actually Fortran. So if you're curious, you can take a look at that. But one of the implications of using a host language is that I could start doing things just purely at a high level. And one of the maybe the controversial design choices was to get rid of if statements and loops. And the reason is that if you look at code, things get really complicated when you see a lot of if statements, because every time you have you kind of double the states potentially each time. And so I just wanted to get rid of those altogether and just run things at a higher level. And so you can do that if you use higher level words like map and group by and higher level constructs like arrays and records. And so I want to show you a quick demo of what that looks like. All right, so now I'm in this, yeah. So this is what Forthic looks like. The right bracket or the left bracket and right brackets are actually words. So I don't have any syntax for arrays. And so if I run this, you'll see that this is what we get on the other side, the 1, 2, and 3. But now you could do things like this. I can map a Forthic string over that array, and you get what you'd expect. You'd get 3, 6, and 9 here. And now and so Brad kind of showed you one way of constructing dictionary objects or records. And I have my own syntax for that. So I use actually rec instead, and I use rec at instead of dict at. So it's very similar. I was happy to see that. But if you run this, then you see this JSON coming out of that. And the other thing that you can do is, this part I love, is no language does stuff like this, where, okay, I want to map 3 times over that I think is going to happen. Well, that's going to happen. And so conceptually, you're working at a higher level, you're manipulating data at a higher level, and you can now do things like more quickly and more conceptually. And so implication of this is that it encourages straight line, one line coding. And so typically, so in Forthic, everything kind of grows in typical languages, they grow in 2 dimensions. So automatically you are kind of getting a very concise representation of code. And so here I have a little of example, which we'll see in a second. We have JQL defined here. So this is the query to grab some tickets, the fields I want to grab. And then this statement here is actually the code that does it. And once you have those tickets, then you can start just building up a Forthic string to things. And so in this case, we grab the tickets. I'm going to group them by assignee. I'm going to get the number of tickets per assignee by mapping length over that. And I'm going to select the ones that have less than or equal to 4 tickets. So it's like, and you could do that all in one line without any if statement, right? And so this is kind of the power here. And another implication of this is that if you break up those chunks of Forthic code, kind of these blobs, and what these look like is a composition of transformations. Each of those blobs of code is like transforming the data that comes before it. And this last graphic here, I think is really cool because it kind of shows everything kind of in one spot. So at LinkedIn, I inherited a Python program, and it was like 1,000 lines of Python. It had 62 structural if statements. So that works out to about 150 million trillion states that this thing could be in. And so you can imagine that's all kinds of awful, but because if you have to debug it, if you need to tweak it, if you need to do anything to it, it's just very difficult. But if you take this approach of saying, hey, we're going to be incomplete by design, I'm going to literally divide this program. I'm going to cut it in, and the top part's going to be this sequences of transformations, which runs in a straight line. And then the bottom is just simpler words that are essentially Forthic words that are being coordinated by those higher level constructs. And so then you get a simplification on both sides of that. And at the top, Forthic is looking like code as transformation. And at the bottom is what we typically view code as code as computation. And that corresponds to computation is like lambda calculus. And transformation, where we have objects and relationships, is category theory. And you can use the concepts from category theory to analyze these things at a higher level. So that's a different talk. So I'm not going to say anything more about that, but there's a lot of powerful things that come out of that. Okay, host languages open up everything. So the first Forth was in Fortran, right? And the reason that, and Chuck is here, so maybe he can say if I'm saying this right, but it kind of worked, but it didn't work well enough. It wasn't performant enough. And so that's kind of this last line that I highlighted here. So Fortran had to go. And that's been kind of I think the direction ever since. But host languages have gotten a lot more capable now and a lot more powerful. And so I want to give you another example of that type of power with the Jira example. So if we come back to here and I go to here, so this is the example I showed you earlier where we were pulling Jira tickets. And what I'm doing here is I have these modules that I'm going to pull in. And I'm going to make a call against the Jira API to pull tickets that were updated in the last 60 days. So if I go to Jira here instead, so I'm going to make that call. So it came back, we got JSON data, that's great. And so Brad did a lot of explanation of how to format this so it doesn't look like this. But I can rely on other things to format. So for example, I have the tickets here, and now I'm going to write them to a cache file. So when I write it to a cache file, it will automatically format it. So we will take a look at that. Actually, I have the cache file. Oops. The cache file is here at the bottom. So when I rerun this, it's going to run tickets, pull them, and then write them into this file. And it's going to write them in a formatted way. And so you see the same data, but now it's formatted in a way that we can manipulate. And then we could just do all kinds of neat things. Like I can take this string here, assignee group by field. So tickets, and I'm going to run group by field assignee, and this will do what you expect. So now the assignees are grouped by, or the tickets are grouped by the assignee. So we have William McLean, Calvin Bentley, etc. And if I wanted the number of tickets, then I could just map the length over that record. So if I run this, we'll get, now we have counts. And so it's just this wonderful way of manipulating data at this very high level. And now you could build, and this is how we built all of these like hundreds and hundreds of web applications for managing projects at LinkedIn. All right, so last, I have one more example. And this is the key thought, is that when you use Forthic inside of a host language, you can embed it anywhere in the application. And so a lot of applications are client-server architecture. And so that means that, well, let me just bring this one up. Okay, so here is an, actually, okay, I wanted to show you the fancy thing. So let me copy this. So what we have here is, this is Jira running. And I built a this org.jql assistant. And so this is an AI agent running in Jira. And actually, I can't now get to this chat box at the bottom. So I have to, can I minimize this? Oh yeah, thank you. It's like this. So I have an AI agent that has a Forthic interpreter integrated into it. I have this application that can run Forthic code. And so what I can do is have the AI agent construct Forthic code that changes the application post-deployment. So I'm not going to deploy anything. I'm not going to recompile anything. I'm going to have the agent write the code and then run it to extend the application. So we can do it like this. So we have a new report for William McLean with an issue graph for BizDev 246 and include a Slack leaderboard. So we got a couple of things going on here. And so it's going to go out. You can see it's running the Forthic engine here. So it's running that built that interpreter that's integrated into the AI. And it's come up with this link. So when I click it, now what we're doing is we're actually running a Forthic program live through this thing. And what's happening here, so there's a lot here. So William McLean is the root manager that we asked for. This is a hierarchy. This is an org chart that goes horizontally. So Leon and then Michael reported to William McLean. These are the, okay, I got 2 minutes. 2 minutes, okay. These are tickets that are part of that graph, this issue graph. And so when I click on this, we recompute all of these things and re-roll them up. And all of these things have Forthic running inside of it. So this, what's happening here, what's recomputing, what's relaying these out is Forthic code. Similarly here, this thing is Forthic code. And when I click on these things are all interacting with each other. And if you look at the bottom here, this is the actual Forthic that is building this. It's kind of small, I guess, but it's one line of code. It's one line of Forthic code is building this whole thing. And that one line of Forthic code is literally in the URL. So that means that I can actually code Forthic right here in the URL and change. And so one more example real quick. The other thing is that because it's integrated into the AI can also understand it. So if I say run Forthic, in that same example, 1, 2, 3, 3 times map. So I can run it directly from the chat. So it's going to run that through the engine. And I could do something like run Forthic, run this Forthic. Same thing, 1, 2, 3, 3 times map oops, sorry, I'm trying to type too fast. A, B, C, swap, zip, rect. I think it could do that. So now that's one line of Forthic code. I built up this dictionary, and because it has the has GitHub inside of its training data, and because Forthic is on GitHub, I can say explain this, and it could use that data now to explain what that line of Forthic code is doing, and it does a pretty good job. It broke it down into. I want to walk over this. It's saying, hey, this is okay. Okay, sorry. Yeah. Okay, I understand. Yeah, you're right. So it's broken it up into the chunks, and it's explaining each part. And so this is very wonderful for people that, for example, like the program managers and the engineering managers that aren't familiar with Forthic, they could start using these types of tools to understand, what's going on. So, okay, so that's the end of my my demo. And yeah, and so the last line is that when you get into these applications, you can make them arbitrarily extensible. And so it's kind of a nice, powerful, because we're using a lot of the fourth power and fourth concepts, but applying them at a high level. Yeah, got it. Thank you.
All right.
Johnson.
My mic. Do I click share?
Sure. Yeah.
Share what?
Sure. Yeah.
Depends on what you want to share.
Let's share my whole.
If it's your whole screen, it's
Yeah, it's that.